part 4, the back page, bottom of the exam review. And I want to remind you about adding fractions, that it must have a common denominator. And remember the denominator, think down. And when we have a common denominator, or don't have a common denominator, we need to find one. So in this case, it would be 10, because 5 and 2 are both factors of 10. And remember, whatever you do to one, you have to do to the other. So we have 4/10 plus, and times 5, 5/10. 4/10 plus 5/10 equals 9/10, because we add numerators, but our denominator stays the same. Think about it. If I have 4 cats and 5 cats, I don't end up with 9 dogs. We stay the same. 4/10, 5/10, 9/10. All right, same thing with subtraction. Again, you find your common denominator. If you're not sure, you can count by 3s and count by 7s and see what's the first number you run into. And in this case, it's 21. So 7 times 3 and 6 times 3. 18 over 21 minus times 7 times 7. 7 over 21. And that would be 25 over, no, sorry, subtraction. 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 18 minus 7 would be 11 over 21. If we had room, we'd work down in a V. I showed you this when, I'm not sure that there's anything like this on the exam, but just in case, we find a common denominator, and it would be 6. So now I have 4 and 2, 6, minus 2 and 3, 6. Now, there's a little drama there because we cannot take the 3 from the 2. We rename the 4 as 3 and 6, 6, because any number over itself equals 1. So 3 and 6, 6 is your 4, and we have 2, 6, so that becomes 3 and 8, 6, minus 2 and 3, 6. Then we can subtract 1 and 5, 6. The 4 is equal to a 3 plus 1. Is that right? And why do I choose 6? Because that's my denominator. So we renamed the 4 and added the 6 to the 2, 6, becomes 3 and 8, 6, minus 2 and 3, 6 equals 1 and 5, 6. Because I cannot take 3 from 2. So I had to rename, just like you would in a regular whole number subtraction problem. All right, this part should be really easy, and I put everything out on the side. You need to label the x-axis, label the y-axis, label the origin, and the points of the origin would be what?
0,
0, 0. You need to name the quadrants. 1, remember to go counterclockwise. 2, 3, and 4. Then you need to tell me where I'm going to find these combinations. So if we go right and up, we have positive, positive. If we go left and up, we have negative, positive. If we go left and down, we have negative, negative. And we go right and down. Okay, so you need to know origin, x-axis, y-axis, and your combinations of integers. Multiplying fractions is really, I think, easier than adding and subtracting because you don't need a common denominator. Numerator times numerator, denominator times denominator. 2 times 2 is 4 over 15. Done. Okay, it cannot be reduced. However, this one we could multiply as it is, but to make our life simpler, we can reduce before, as long as we reduce one numerator with one denominator. And I can reduce, I could reduce the 4 and the 6, or I could reduce the 3 and the 6, but I cannot do all 3. So if I divide by, whatever you do to one, you do to the other, divide by 2, divide by 2. 2 over 3 times 3 over 7. Oh gosh, I can reduce again, because they don't have to be in the same fraction. Divide by 3, divide by 3. Now I have 2 over 7 as my answer. Okay? Okay. On your worksheet, it says to know everything on pages 324 to 326. It's all about integers, practicing. It's a great place to practice. Also, that there's another page listed right after that. Good integer practice. Find percent of a number. When I say of, if you don't know what else to do, multiply. When we drop the percent sign, we move the decimal 2 places. Okay, 0.25 times 80. Now, when we multiply by a decimal, we count. How many places in the problem behind the decimal? 2. How many places behind the decimal in the answer? 2. Do I have to have the zeros? No, I don't have to. Can I have them? Yes. Answer's 20. Or another way you could think of that is 1/4 of 80. And that's a fourth of, if I divide in 4 parts, would be 20. All right, you need to know the rules for adding and subtracting, or what word do I use instead? Combining. Combining integers. Okay, so same sign, sum, keep the same sign. By that I mean, if I have -6 combined with -3, don't confuse yourself saying subtract. Think about it, it's combining. I have a -6 combined with a -3. They have the same sign. So I take the sum and keep the same sign. Same sign, sum. You're going to have a few problems like this. So make sure you practice, and you can go back to that page 324 to 326 to do some practicing. All right. Now, what if we have different signs? Different sign, difference. Keep the sign of the number farthest from 0 on the number line. That is the number that has that is the same as the absolute value. And what does absolute value mean? Distance from 0 on the number line. So a -7, and those straight lines mean absolute value of -7 is 7. The absolute value of 8 is 8. All right, so absolute value. So let's talk about the difference between two numbers. So if I have -7 plus 2, I take the difference between the two numbers, which is what? What's the difference? 5. And keep the sign of the number with the highest absolute value, negative. If I have -9 plus 10, again, different signs, take the difference, which is what? 1. And what sign's farthest from 0? Positive. And do I have to put the positive sign? No. No, no, no. All right, let's talk about, then I could land up confusing you with this, because then we're back to an old-fashioned problem, but some people get confused. Different signs, what? Difference. And what's the sign farthest from 0? Positive. So that's what we're used to seeing in the 9 minus 6 kind of problem. All right, don't forget the whole sleepy man deal. Whenever we have two negatives, it becomes a positive. So 6 minus -7. And really what it's saying is 6 combined with the opposite of -7. What's the opposite of -7? Positive. So this problem, the little sleepy man, becomes 6 plus 7, which is 13. All right? Do you remember that when you're adding and subtracting? All right? Multiplying and dividing integers, same thing. Multiply numerator times numerator and denominator times denominator. So, oh wait. So, this is going back to the fractions. I was having a throwback. But let's multiply and divide integers. Sorry about that. And we have some rules for those as well. All right, let's go back to the fractions for a minute, because I did want to remind you again that you can reduce before you multiply. Divide by 4, divide by 4, divide by 3, divide by 3. and you would get 1 over 6. Okay, going down, this is what I wanted to get to. Can you divide fractions? Yes, but you have to multiply by the reciprocal, or the flip, or the flop. Do not reduce until you change from division to multiplication. Can it be done mathematically? Yes, but for right now in your life, don't confuse yourself. Flip it or flop it and then do it. Now make sure you do not flip the first number. It's only when you change the sign of multiplication that the second number flips out and becomes the reciprocal. So, if I have 2/3 divided by 1/6, I rewrite it as 2/3 times 6 over 1. Notice the first number stays the same because I didn't change anything. It's only, just like in science, for every action is an equal and opposite reaction. When I change the multiplication, it goes to division. All right, now goes to the reciprocal. Now I can reduce by 3. Divide by 3, divide by 3. 2 times 2 is 2 over 1. Good rule, any number divided by itself equals the number 2. All right, do you understand that we don't flip and we don't flop until we change the sign? So, the first number comes down. It's only when we change to multiply that it flips out. And then we would have 21 over 5, which if I told you, you would need to change to a mixed number, or I may say you can leave it improper. Again, just reminding yourself, chapter 8 is real important with all your integers. All right, now here's another one. You're going to need to know the sign of the answer. And it's just reviewing your multiplication and division rules. So a negative times a positive will always give you a negative. A positive times a negative will always give you a positive times negative. Negative. It's the same as this. All this is your commutative property. You've changed places. All right, a positive times a positive. A negative times a negative. A positive divided by a negative. Negative. A negative divided by a positive. Negative. What is it? Negative. Positive divided by positive. Positive. And negative divided by negative. Positive. All right, most of you knew, but there were a couple of them y'all got stuck on. So if you need to write it down, write it down. It is on the test, I promise you. All of these. So write it down. Negative times positive, negative. Positive times negative, negative. Positive times positive, positive. Negative times negative, positive. Positive divided by negative, negative. Negative divided by positive, negative. Positive divided by positive, positive. Negative divided by negative is positive. Okay, so I hope you wrote it down. We're going to move on. Actually, I don't know that this is even on the test, except every time I've seen a standardized test, they seem to ask you Pythagorean theorem. I don't know if it just sounds cool or what, but it is good practice with set up, substitute, solve, especially if I give you the formula. A squared plus B squared equals C squared. I mean, really? Now, what it tells you is that if we have a right triangle and we know one side and we know the second side, we can figure out the side opposite the right angle, which is called the hypotenuse. I'm not getting all deep into that. This is more about set up, substitute, solve. All right, so if we have this triangle and I set up A squared is 3 squared plus B squared would be 4 squared equals C squared. Now, you know PEMDAS, do parentheses, exponent. So 3 to the second will be 9 plus 4 squared equals c squared. Then we do more exponents. 9 plus 16 equals, keep your c squared, 25 equals c squared. Now, we talked a little bit about square roots. What number times what number gives you 25? What number times itself? Yes. So what we're really doing, and like I said, is taking the square root. It kind of looks like a division sign. And what is the square root of 25? That means what number times what number equals 25? 5. What number times what number equals c squared? C, because c times c would be c to the second power. C times c is c to the second power. So 5. And this is the one they usually like to give to you anyway. 3 squared plus 4 squared equals 5 squared. It doesn't always work neatly like that. It does not mean that if 6 squared plus 7 squared is going to equal 8 squared. But the big deal here is that you can substitute in the 3, the 4, get your exponents, and get 25. And c squared. What number times what number equals 25? 5. And that's your answer. Because 5 times 5 is the same as c times c. All right? Anything on this sheet is fair game for the exam. Anything we've covered, actually, is fair game. You have about over 100 problems. I think it's 101, give or take some. You have an hour and a half for the exam. You need to practice. Good luck.